The particle shown is accelerating down a smooth slope. We want to find the angle of the slope. In other words, we want to find this angle, which I've marked as theta. If we now consider some forces, the weight of the particle will act vertically downwards. There will be a reaction force, and this is always perpendicular to the surface. We can split the weight into components. We should be used to this, but the component perpendicular to the surface is 0.2 g cos theta, and parallel to the surface is the sine, so we get 0.2 g sine theta. There's no frictional force since we're told that the surface is smooth. The acceleration is in this direction, and the reaction and the 0.2 g cos theta must be in equilibrium. And we can ignore the 0.2 g since we've put the components on, and the components have the same action as the weight. As discussed, the R, the normal reaction force, and the 0.2 g cos theta, the component of the weight perpendicular to the surface, must balance each other out, since the acceleration is directly down parallel to the surface. The only force acting in this direction is the 0.2 g sine theta. So using F equals ma, the resultant force is the 0.2 g sine theta. And this must be equal to the mass times the acceleration. The only unknown here is theta, so we can rearrange to get sine theta is 0.2 times 3.8 divided by 0.2 times 9.8. Note here that the 0.2's cancel, so the mass of the object is actually unimportant here. We can calculate this, giving us 0.387 and so on, and then theta will be the inverse sine of this number, and this gives us 22.8 degrees, correct to 3 significant figures.